Hey everybody, it's me. I'm back. You might ask where I've been, as though you were Jay Mascis from Dinosaur Jr. I got sick. But before we get into what's been happening in the time that I've been away, I want to say thank you to the patrons who are sponsoring this very video. Okay, if you want to patronize, you can link in the description. It's available for you and for me, obviously. Thank you. Okay, so last time I was talking about transitioning from a prototype to a finished product, or I guess more a printed PCB anyway. And I hadn't previously designed a PCB, but I did. So I downloaded KiCAD and I got a PCB designed, and I encountered a minor issue that drove me totally nuts. So it was a little bit of a superfluous thing. It was a change that I made that I didn't need to make, and probably a couple errors, compounding one on top of the other. But let's take a look at what I ended up with. So here is the thing. I'll do a little a close-up preview, do some beauty shots of it right now. I went with Blender Blue for the board. There's my logo and the Blender logo in the top. And the root of all the problems, and something that was not in the initial design spec, is this rotary right here. Because I hadn't used stuff before, I did a bunch of video tutorials. I did a bunch of learning online, and I spent a few days playing around in KiCAD trying to get my feet wet to understand how everything worked. And I ended up feeling like I had a fairly satisfactory understanding of KiCAD. Then I went into the actual design process and discovered through various errors that I did not do, something right, obviously. So the advice that I was given was keep everything at default if you don't know what you're doing. That's what I did. But there were a few default things that didn't cover this particular use case. So among those was footprints for the Raspberry Pi Pico and the Cherry MX compatible Kale key switches. I know what you like. So I ended up finding those footprints online from a couple of users. I'll link those in the description. Everything seemed fine. I had to modify the Pico. This may be where some of the errors start to creep in if I haven't already made some errors that I'm not even aware of. I had to modify the Pico footprint because the design of the board mandated that everything be kept as slim as possible. So I mounted the Pico over top of a couple of the switches on the board. So you've got to be a little careful when you're wiring it up. But the issue there was that the debug pins on the Pico overlapped with a couple of the key switch pins. So I ended up creating a custom footprint that had the debug pins removed. Maybe there was a better way to do that, but that's what I ended up doing. So with all that done, the schematic looked good to me, the board layout looked good to me, and I ran the design rules checker, the DRC, and I got back about 100 different errors. And at first I was really discouraged because I thought, I must have done a million things wrong. Looking back, I think maybe I did one or two things that were very important at the beginning wrong, but all of the errors that it gave me were not errors. Every error was saying, this header is overlapping this, socket, but that's the socket that it's supposed to go into. This trace is touching this. Well, yeah, of course it's touching that because that's how it's conducting electricity. That's the reason the trace is there. So most of the errors, or actually all of the errors, were just things that I must have set something wrong because they weren't errors. They were, the header pin was going where I wanted it to go. The Pico was going where I wanted it to go. The trace was running from the one to the other. And, it's not a problem that it's making contact with both of them because that's the entire point. So I don't know what I did there. But everything looked good to me. And that is where I took a chance. I rolled the dice and I just got a run of PCBs made. So that got me this sucker here. And as I alluded to, I made a critical error. So there was one step that I tried to keep everything as similar between the prototype and the finished as I could. But there was one step where I switched a couple of buttons around just because running the traces on the board, it made more sense to put them in different pins versus when I was doing the hand-wired prototype, I was just running cables, running wires. I could run them as long as I wanted to. So I switched that up, and not realizing, I put it in an ADC pin, or I should say, putting it in an ADC pin comes with some catches that I didn't realize. So everything on this revision, on this board, takes its power from VBus, which supplies 5 volts DC. The ADC pins, even though you can go code-wise and say, treat these as standard, digital GPIO pins, just treat them exactly the same as all the others, they max out at, I think it's 3.3. It's either 3 or 3.3 volts. So if you supply them more than that voltage, then basically they just leak between the pins. So what was happening was I was turning the knob on top, which was intended to navigate frames along the timeline. When you roll it back and forth, and when you press it, it plays and stops. And it was playing and stopping every time I rolled it back and forth. So clearly one of the pins was being triggered no matter what happened. And then I posted about it in a KiCAD forum. I had a very helpful user point me in the right direction, and I ended up sorting that out. So did a little minor surgery to this board, and I gave it, the modification that it needed to only receive 3 volts. And of course, now it totally works. So that is the status of the design at this point. I know where I need to tap power from if I wanted to leave the design unchanged. The rotary that I have, I can just remove, and then the commission is essentially satisfied at that point. The device is complete for the original design spec. But yeah, now I'm at the point where I can make a revision and I can send off for a new set of boards. But that was kind of the least pleasant part of it all for me. I had first contacted some places local to me and asked if they would be able to, do short runs, do initial runs on these boards. And they basically just said, oh, just upload it online. Just upload your design to some place. They'll do a design check on it, manufacture it for you. You have it in the mail in a couple of days. So that was a little bit disheartening because I was kind of hoping to keep it local. I realized that I'd probably pay a premium on the boards for having them made with local labor, but that was worth it for me in terms of the trade-off there with the shipping cost, which ended up being gigantic. So my first choice was I tried JLCPCB because I'd seen a lot of people talk about them. And they had a per board cost of $2, which was great. But all said and done with shipping and taxes, plus a $40 remote location surcharge, it was going to be more than $100 to get 5 boards into my hand. So I checked out PCBWay, and they came in just under $100. So that's what I did. But yeah, that's not really that great an experience. 5 boards for $100, and shame on me for not doing more research. If there is a local place that wants to do these prototype runs, I'm going to look around for a different supplier. In terms of the boards, the quality is fantastic, and when I could not figure out what was wrong with my rotary encoder, I was really tempted to blame a manufacturing error on who was it? PCBWay, but then the legion of PCBWay defenders jumped down my throat, and rightly so, because it was indeed an error in design, not an error in manufacture. So in terms of the board quality, they are excellent. The silk screen looks like it should. All the boards check out the way they're supposed to. It's a shame it was as expensive as it was, because it's really kind of put me off doing another run, especially when I'm in that case where I'm like, oh, I'll just tap it from, the 3 volt instead of the VBus. But is that 100% gonna, fix all my issues? It should. It's the only thing that I would change, but I've already been in the position of, yeah, I think it all looks right, and send it off and spend all your money, and then you get something that goes, oh, right, there was something I didn't really entirely account for. So yeah, then I got sick. And then I got better, and then I still didn't know how to fix the thing. So now that I finally fixed the issue, the project is back on track. Yeah, I'll do some more beauty shots so you can see the finished PCB. I just have it on spacers right now. I don't have an enclosure for it quite yet, but you know, if this is, again, if this is something that you guys want, please by all means let me know, because like I said, it's getting to be an expensive endeavor for me to do another run of boards if it's just for me and Pierre kind of thing. But yeah, if you think you are interested in this, I can also upload the Gerber files. That was my intent from the beginning. But again, now that I've got an error on my board, and now that I have to make changes, I would really like to be able to test those changes before I upload the file. But I don't know, maybe the best solution is to upload the file, the original, and maybe the changed one too. Just put them all on that repo on GitHub, and then somebody else can test it and verify if the community is interested. But yeah, that's the thing. Oh yeah, and one more tiny little stupid thing. I was looking at adding a reset button, and I wanted it to be recessed to be not really that accessible. So I decided I'd just add one of those basic standard buttons that came with the Raspberry Pi. And I measured the shaft of the button, which measured 6 millimeters. I found the 6 millimeter button footprint in KiCAD, and I dropped it in. And then I realized I should have been measuring the base, which turns out I was measuring a 12 millimeter button, which has a 6 millimeter shaft and a 12 millimeter base, whereas the 6 millimeter button has a 6 millimeter base and I'm guessing a 3 millimeter shaft. Yeah, that's it. Bye.